Hello everybody, my name is Muhammad Ihsan Jamba. I'm talking on behalf Siti Inayah Rizky Hasanah and Denny Matthew Saputra. We are from Faculty of Computer Science, Sriwijaya University, Indonesia. In this opportunity, I will talk about our paper, Dimensional Reduction Methods Comparison for Clustering Result of Indonesian Language Text Document. In the background of this research, it was starting from the need to cluster the Indonesian language journal papers. As we know, the data derived from the text documents contain many attributes or dimensions. So they are categorized as high-dimensional data. In data mining, especially in clustering process, high-dimensional data can be an obstacle because the clustering algorithm only works well on the low-dimensional data. To improve the performance of the clustering process on high-dimensional data, it is necessary to reduce the dimension of the data. We know that there are two methods of dimension reductions, which are attribute selections and attribute extractions. Of course, with all advantages and disadvantages of each method. For these reasons, in this research, we want to know the difference between the results of the high-dimensional data reduction by using selecting attribute by singular value decomposition algorithm and extracting attribute using principal component analysis algorithm. This is our methodology. From the text document data, we pre-process using PFIDF methods, and then we get the data converted into the word weighting. After that, we clustered the data using K-means algorithm. There are three kind of testing we already done. The first one, we cluster using the K-means only. The second one, before clustering, we reduce the dimension using the SVD, yeah. And the third one, before clustering using K-means, we reduce the dimension using PCA. But before we do all of this, we should know how many K of K-means parameter it should be the best one. For that reason, we use K-means dynamic algorithm to find the best number of K. After that, we will compare all the results in terms of DBI, Davis-Bouldin index, and the computation times, of course, and also the iterations numbers of K-means process. Using K-means dynamic clustering, we found that our data is the best results will be get if we use the K numbers as 7. Using the K-mean dynamic clustering, we find that the best clustered number is 7. After that, we use the K equal to 7 to cluster the data using K-means only, using SPD plus K-means, and using PCA plus K-means. All the observations, as I mentioned before, are DBI, Davis-Bulden index. The second one is computation times of the K-means and the number of iteration of K-mean process. The result were analyzed statistically using ANOVA statistical method, analysis of variance. In this research, we use SPSS software version 24 as a tools. Okay, the comparison, try to compare the 3 groups of the results, yeah, from the K-means only, SPD plus K-means, and PCA plus K-means. And to find the differences, which one the differences is make the difference, we use the post hoc test using 2 key method. And this is the results. For the DBI, we find that differences between the groups of compared, yeah, where SVD is the best one. The PCA, although it was give the lower DBI than K-means only, but the differences is not significant. For the computation times, there are 3 groups of subsets. It shows that all of 3 groups have significant differences statistically. And the PCA have a higher computation times than the K-means only, but SPD lower than K-means. And the last one, the iterations, the significant shows that statistical is significant because it's lower than 0.05%, 0.50, it's 0.49, but the significant numbers shows that it's not the best one to show the significantly difference. Here we find that SPD plus K-means equal to PCA plus K-mean, but PCA plus K-mean equal to K-means. It means the differences in not make it very a little bit differences. As the result, we conclude that this research using the 100 Indonesian language journal, which converted into 8,250 words or attributes. We clustered using K-means with K numbers equal to 7 as ideal K value, and all the tests repeated 30 times for each method. We compared statistically for the average DBI value, computation times, and number of iterations. We find the DBI value was significantly different. Also, the computation times and a little bit difference between the subsets of the comparison in iterations. For the last conclusions, we find that clustering methods using singular value decomposition reduction technique give better effect than PCA, yeah, against the K-means methods. Here some diagram shows that here the DBI value for K-means, and then drop DBI value when reduced by SPD, but PCA reduce DBI, yeah, a little bit lower than K-means only, but the differences is not significant. For the computation times, here this the K-means only. SPD is the faster, but the PCA is lower than K-means only. For the iterations, there are differences significantly when we compare between K-means only and SPD, but no differences significantly between K-means and PCA. So the conclusion from this research, we understand that to improve the output of a good cluster, a dimension reduction is needed before grouping the data. Here we determine the effectiveness of the data clustering method indicated by DBI value, that's a smaller DBI value, faster computation time, and fewer number of iterations. From the results, we find that in average, DBI value by SPD reduction give 23.53% better than K-means only. Also, in computation times, the clustering process average 0.132 seconds more faster than K-means only. And for the iterations, the number of iterations become less in average 5 repetitions. So in conclusion, we find that the effective reduction technique for the grouping text data in our Indonesian language journal papers, in our Indonesian language text document, more better if we use SPD as a reductions method. That's all for my presentation. Thank you very much. Goodbye.